All right, so if you haven't watched the how changing variables and different functions video changes the line or the shape of the graph, you should watch that before you watch this. But this one is some examples from lesson 7, and it's effectively just how things change when I change a, right? The term a and all these different things, right? So we have a parabola, right? So the right here we have three parabolas. Let's see. We have this red parabola. We're going to call it g sub x. So this is g sub x. And then we have a blue parabola. We'll call that h sub x. That's not blue. We'll call that h sub x. That's this one. And that is going to be this one right here. It's narrower. And then we'll have to do like how about a green or pink? We'll do pink. All right, and then we have this k sub x, which is like a reflection of h sub x, meaning that like all the points on all the y and xy values for this, the x values will be the same, but the y values will have the opposite sign. So like +3 is -3 down here at negative, or sorry, it's like 2, and actually this one looks like it's a reflection and it changed. It stretched a little bit, and so it stretched a little bit too. So it's a reflection and it stretched a little. Okay, so the a value changed. All right, so let's go ahead and recognize some of the standard equations for this, where you have the y value, where y is any one of these, equals the vertex form, which is my favorite, a times x minus h quantities squared plus k, meaning that the h value is the negative x value of the vertex, right? So the vertex is 0 and 0, right, for all of these, so we don't have to worry too much about that, right? And the k value is the y value of the vertex, and again, it's 0, right? So the h is 0, and so is k. They're both 0, right? So the only thing that is really changing in all these is how much it stretches or if it's flipped. Okay, so this one is going to have a negative a value. And remember, a is the rate of the comparison of a change in y before a change in x, right? This black one, g sub x right here, you can see it's a 1-for-1, right, change in x. Here it looks like it started off as a 2, right? So that is going to change the rate of change for these things, keeping in mind this x squared thing here. Okay, so let's go ahead and fill out some of the answers here. So in g sub x, that is the red one, it's asking us what the coefficient of x squared is. Well, the coefficient of x squared for this one is going to be 1, right? Because when x is 1, right, y is 1. Okay, the coefficient in h of x, right, and also look, that is 1 as well, right? That's a 1h, that's a 1x squared. So there's an invisible 1 right here, an invisible 1 right here. Okay, and then h sub x, the coefficient of h sub x is equals 3x squared. That's this one, right? They're saying that this is g sub x equals x squared, h sub x equals 3x squared. It's supposed to be blue, 3x squared, and then k sub x is -2x squared, -2x squared. So they give us the equations up here in the top, right? So the coefficient of h of x, which is my blue one, is 2, right? Or excuse me, it's 3, right? The coefficient is 3, right? And then the y values of h of x can be found by multiplying the y values of g sub x. Well, let's evaluate that. So it's asking me, hey, look at my y values of my blue and my red equations, and I find the y. What is the multiple difference between this one and this one? Well, it's 27 divided by 3. Oh, so is okay. So and then we have 12 divided by 2 is 6. 3 divided by 1 is 3. All right, so every time, because of this x squared, it goes 3, 6, 9. All right, so it's adding 3 to each time of that multiple. So the x can be found by multiplying the y values by 3. Okay, the y values of h of x can be found by multiplying the y values of g sub x by 3, right? So I multiply 9 by 3, I get 27. I multiply 4 by 3, I get 12. I multiply 1 by 3, I get 3. Okay. The coefficient of negative 2x squared, as you guys should know this, is negative 2. Negative 2. All right, so previously notice, hey, I can find the x values, the y values by multiplying it by the coefficient, right? So if that is kind of continue to trend that way, if I have my original function or my g sub x is my standard x squared, that's my parent function, right? And I want to flip it, I make a negative, right? And then the rate of change is going to change to 2, so it's going to be the coefficient, which is negative 2, right? Because for every you can see here's a negative 2. It's going to change. It's going to go up faster, right? It's going to go up faster than h sub x. Okay, I'll go down at a faster rate. Okay, so then here we go. We have the table of these are shown, right? And it looks like x is going down by 2 each time, and the change in this one is going. It goes from 4 to 7 to 10 to 13, 7, and so it's going up at each time. Because a of 3 times x, it can be, now you want to divide things by 3. The values of the x values of a sub x will be divided by 3. Okay. So here is 3 functions right here. And we have r sub x, t sub x, and w sub x. And then we have these are absolute value functions, and they're defined. R sub x is right here. That's r sub x. And then we have, which is also right here, r sub x is my middle one. It looks like it's a 1-for-1 change. It's pretty obvious to see here. Negative 2, it went up 2. 2, it went up 2, right? So the t sub x looks like it goes up at a rate 4 times faster, right? So t sub x, it's this one, right? So let's make that one red. T sub x changes 4 times faster, right? This is a little easier to conceptualize because they're linear in nature, right? So this, for every 1 change, it went up to 4 for t sub x. Okay, and then w sub x is a half, is 1/2 for every 2 change. It takes 2 changes in x to only go up only 1 in y. So that's a 1/2 rate of change. Okay, so the x values can be found by dividing x values of t sub x. Remember, r sub x is my parent function, so I can divide the x values by 4. Right, because I have the parent function. If I have the y values, or if I have the x values, it's a 4-to-1 ratio. So I'm going to divide it by 4. The x values of w sub x can be found by dividing by 1/2. So all you have to do is divide by the coefficient, or the a term, right? So this is going to be 1/2. Okay, so just divide by your a term, or your coefficient. Okay, and here are 2 linear lines, right, where p of x is equals x, and y and q of x equals negative x. Well, actually, it looks like it's not a 1 for 1. It looks like it's a 1. It's hard to say. Let's see. For every, it's like every. Let's look. Looks like every. It's even asking us the question. What do we have to ask? What do we have to answer? What is the effect of the table in f sub x was replaced? What is the effect on the table of values in the x of p sub x? So this p sub x was replaced with negative x, right? So all you have to look right here is, hold on one second. I'm trying to figure out what they're asking. It's a funny way to ask it. Oops, where did it go? There it is. Okay. What is the effect on the table when the values and when the, what is the effect of the table of the values when the x in p sub x, okay, is replaced with a negative? Okay, so it looks like when I replaced a negative with that, it is the y value changes. It's like the y value changes to be opposite of that. Oh, I see. Okay. Yeah, so if you look here, it's in kind of weird order. If I change this to 2, right, the value stayed the same. If I change this to -1 to 1, the values stayed the same. If I can't really change values of 0, so that number's the same. If I change this to 1, right, to -1, and I swap it, it's -1, right? So what it's telling you is, hey, when I swap the values, it swaps the y, the x values. It swaps all the different values because there's the same rate of change, right? So the y values change to the opposite x values. The values changed to that of the opposite y x values. Okay, so then it's asking me what is the effect on the graph when p sub x when it's replaced to create when x in p sub x, okay, is replaced with negative x to create q sub x of the graph. Okay, so what is the effect of the graph? So the table changes one way. The graph, it's just going to reflect. It's going to flip over the x-axis because the y values are going to be the same. Y values are the same, so it's going to stay there, right? But you can see that every y value for the x's are the same value away from the y-axis. So it's a reflection across the y-axis. Okay, so hopefully that makes some sense. And just recognize to change things differently, to swap them. This is just saying, hey, this is a reflection. This is trying to show you what happens when I change the x values to the opposite x value. It reflects across an axis. So that's all I was trying to tell you there. All right, so hopefully that makes sense, and we'll move on.